everyone. Today I'm here with video number 2 from lesson number 5, periodic classification of elements. In the previous video, we have studied two laws that were the Bernier's triads and Newland law of octaves. Then next contribution was of Mendeleev's. We will study about Mendeleev's periodic table in this video. Newland has discovered about 56 elements in his periodic table, and next contribution was of Mendeleev. His full name was Dmitry Ivanovich Mendeleev, and he was a Russian chemist, and he was the first person to make a significant contribution in the formation of periodic table. At that time, when he started up with his work, 63 elements were known. He tried to correlate the atomic masses of the elements with their physical and chemical properties. Among the chemical properties, he concentrated mainly on the behavior of hydrides, that is compounds with hydrogen, and oxides, that is compound with oxygen of the element. He carried out his research for many years. Then he came to the conclusion that when elements are arranged in order of their increasing atomic masses, similar properties of the elements reoccur on repeated after definite gap of atomic masses. This is somewhere influenced with the Newland's law of octaves, but he said every 8th element was showing the same properties, but Mendeleev said that the property is repeated, but he was not sure with the number of the element. Then he summed up his conclusion in the form of a law that is known as Mendeleev's periodic law, and it was given in the year 1869. And according to this law, the properties of the elements are the periodic function of their atomic masses. And repetition of similar properties after a definite gap is also known as periodicity in the properties. Now, how he did this discovery? He arranged 63 elements in order of their increasing atomic masses in the form of a periodic table. Elements with similar characteristics were present in vertical rows called groups, and horizontal rows were known as periods. Let's see this. Now you can see here the main characteristics can be briefed up like that. In the periodic table, the elements are arranged in the vertical rows called groups and horizontal rows called periods. You can see in the slide that there are 8 groups from 1 to 8, and elements belonging to the first 7 groups have been divided into subgroups, which are A and B, on the basis of similarities in the properties. The elements that are present on the left hand side of each group, they are forming A subgroup, while those on the right side forming B subgroup. And group 8 is consisting of 9 elements which are arranged in 3 triads, means each is having 3 elements. Then there are 6 periods. You can see here from number 1 to 6. Horizontal rows in the Mendeleev's periodic table. In order to accommodate more elements, the period 4, 5 and 6 have been divided into 2 halves. Okay, and first half of the element are placed in upper left corners, and second half occupies the lower right corners. So this was the description of Mendeleev's periodic table. He took 63 cards, and on each card he wrote the property of each of the element. Then he grouped the elements with similar properties And he also kept in mind that they should be arranged in increasing order of their atomic masses also. And then he observed that there is something periodic occurrence, means something is getting repeated after certain elements. And then he gave this law of periodicity. Okay, so majorly there were 63 elements, and he made a very good contribution in the periodic table because it is forming the basis of the modern periodic table. He gave very good explanation for different groups, rows, periods and everything. It was clearly mentioned in the Mendeleev's periodic table. If we talk about what were the basic advantages of Mendeleev's periodic table, then you can say that Mendeleev was the first time he arranged very large number of elements into group and periods, and this made the study of different elements quite systematic. If we consider the property of element in a particular group and those who were not there, they were being predicted. One more important thing he did was he laid more stress on the similarities in properties rather than on increasing the atomic masses. So whenever a particular element did not fit in the arrangement, he left the gap in the periodic table. Thus, many gaps for the undiscovered elements were left in the periodic table by Mendeleev. So this was a thing that wherever a discovery will be made, those elements can be accommodated. He did very nice space for noble gases because noble gases were not discovered at that time, but he properly placed a proper arrangement for them also. Then he did the correction of doubtful atomic masses. Okay, what happened there? Like beryllium has been assigned atomic mass of 13.5. Okay, and it has a valency of 3. But later he found that atomic mass of beryllium is 9.0 U. So this was also a major contribution of Mendeleev, and many other elements also he corrected the atomic masses. They were along with beryllium, it was indium, beryllium and gold also. Next, Eka elements predicted by Mendeleev table. What is Eka elements? You can see in the slide, he left certain green blocks are there. You can see it beneath boron. Then you can see it in the side of the zinc also. Then with the aluminium also you can see a green color block is there. So what is this? This is he left the empty spaces for the future elements, and he added a prefix Eka meaning 1 which are having the same properties like Eka boron, Eka aluminium and Eka silicon. And later on this Eka boron was named as scandium because it is having similar properties with that of boron. Eka aluminium, similar properties, name was given gallium, and Eka silicon was given germanium. So these were the elements which were discovered later, but Mendeleev has put some spaces in between so that they were easily fit in the periodic table without any disturbances. Though his periodic table was very much appreciated, but there were certain defects also. Let's see what were the defects. Position of hydrogen. In periodic table, hydrogen has an atomic mass 1 and it has been placed at the top of group 1A. But 1A is representing the alkali metals. So hydrogen is not an alkali element. So both hydrogen and alkali metals, they have different properties. So position of hydrogen was not being placed by Mendeleev, though it is there in modern periodic table also. But if we are talking about defects, this is one of the defects in this. Then there was anomalous position of some elements. If you go back to the periodic table and if you see there, then you will see that in Mendeleev periodic table, elements have been arranged in increasing atomic mass. But in some cases, element with higher atomic mass is written first and then the lower atomic mass. For example, argon, it has atomic mass of 39.9, and after that it is potassium, that is 39.1. Similarly, cobalt has an atomic mass of 58.9 and it has been placed before nickel, which is having atomic mass of 58.7, and no justification was given for such anomalous position. Anomalous means which was not very clear, some disturbance was there in the periodic table. Next effect was isotopes. You all know, I think, isotopes of an element, they have different atomic masses but they have same atomic number. So the place for isotope was not given in the Mendeleev periodic table. Like, you know, isotopes of hydrogen, it is protium, deuterium and tritium, but they have only one position in the periodic table. Similarly, if we talk about chlorine, chlorine is also having two isotopes with a mass number 35 and 37. They also do not have any proper position in the periodic table. Then there was no correlation of elements in the subgroups. According to Mendeleev, the elements were placed in the same group must resemble their properties, but there were no similarities among the elements in two subgroups. For example, if you say lithium, sodium, potassium, they are present in 1A. They are having similar properties. But if you see 1B, it is having copper, silver and gold. So they are not having any correlation with the elements of 1A. Different groups of similar for similar elements. In some cases, the elements which were having similar properties, they have placed in different group. For example, copper and mercury, they both resemble in many characters, they both are metals, but copper has been placed in the group 1B while mercury has been assigned the position of 2B. So there were not any justification for this change of the position of the elements. There was no cause of periodicity, means there were no proper explanation for the fact of stating why the properties of the elements are getting repeated. He was not having any answer for this question. At last, I can say this, that Mendeleev periodic table has suffered certain defects, many defects we are seeing here, but his efforts were highly appreciated because he was the first person who gave this rows and columns and everything in his periodic table, and therefore he is regarded as the father of the periodic table, and his work was actually the motivation for the discovery of many new elements at the later stages. So this completes your Mendeleev periodic table. In the next video, we will start with modern periodic table. Thank you so much.